Now the continuation of dual nature of radiation and matter. In this we can see Einstein's theory of photoelectric effect. See, in this Einstein theory of photoelectric effect that explained the photoelectric effect, which is on the basis of Planck's quantum, the theory which according to what light radiation travels in the form of discrete photons. So when a photon of energy h nu which falls on a metal surface, the energy of the photon is absorbed by the electron and is used in two ways. The part of energy which is used to overcome the surface barrier and come out of the metal surface. So this part of the energy we calling as the work function, that is phi, which is equal to h v naught, and the remaining part of the energy which is used giving the velocity v to the emitted photoelectrons. This is equal to the maximum kinetic energy of the photoelectrons, that is half mv square maximum. So m, which is mass, we know that, right? And see, the photoelectric emission is the result of interaction of two particles and the energy of each photon, which is nothing but what, h nu, right? And the photoelectric emission, which it contains two particles, one a photon of incident radiation and the other one is an electron of photosensitive metal. That only we said the energy h nu of the incident photon is used up in the two ways we said, right? So according to the law of conservation of energy, we can say h nu which is equal to phi plus half mv square, and we can apply phi value here, work function value h nu naught plus half mv square maximum. Then half mv square, which is equal to h into h nu minus hv minus hv naught. So that is equal to hv minus v naught. So this we can call it as this equation is Einstein photoelectric equation, that we can that it helps to use explain the photoelectric effects of explanation of effect of intensity and the effect of threshold frequency and the effect of the explanation of kinetic energy. This helps to explain all those things, right? And now we can see the verification of a law of photoelectric emission based on Einstein's photoelectric equation, right? Now we know that half mv square maximum, which is equal to h v minus v naught, is the photoelectric equation, Einstein photoelectric equation. From this, if v is less than v naught means what will happen? Half mv square is negative, which is not possible for that, and therefore the photoelectric emission is to take place of v always greater than v naught only. This condition will satisfy. And then since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to the intensity of incident light, and it is clear that half mv square is directly proportional to v, right? So, and as h and v naught are constant, and this shows that the kinetic energy of the photoelectrons is directly proportional to the frequency of the incident light. And for the time lag, the photoelectric emission is due to collision between a photon and an electron. As such, there cannot be any significant time lag between the incidence of photon and emission of photoelectron. So that means the process is instantaneous. It is found that a delay in only 10 power minus 8 seconds. So the explanation part of the time lag also is satisfied. So the equation, that means the Einstein's photoelectric equation, helps to explain the law of photoelectric effect in the form of the intensity, effect of intensity, threshold, kinetic energy, and as well as the time lag. Now, what are the applications of the photoelectric effects? See, a number of application field which we are using the photoelectric effect actually. See, automatic fire alarm, burglar alarm, scanner, and we are using reproduction of sound in cinema, paper industry, locate flaws or holes in the finished goods in a number of application field which is there. And also we have like from this photoelectric effect we can get the photocell. The photocell or a photoelectric cell is an arrangement which converts light energy into the electrical energy, and also it is works on the principle of photoelectric emission. So this also we have in the photocell in these form of applications we are using, right? So a number of application field oriented things which is there you are seeing on the screen, right? And dual nature of radiation and matter of the light, it has the dual nature. So the dual nature of radiations, we can say the phenomenon like interference, diffraction and polarization or can be satisfied on satisfactorily explained only on the basis of the wave nature. On the other hand, we can say the the phenomenon like photoelectric effect, all those things that can be explained only in the term of quantum theory, right? See, by assuming particle nature of electron or particle nature of light, this shows the light radiations has dual nature. Is it right? So it sometimes behaves like a wave and sometimes as a particle, right? So de Broglie, he suggested that the particles like electron, protons, neutron, that and all has dual nature, and that is they have also can have the particle as well as the wave nature. By you may see from the chapter 10, 9, 10 and now you are seeing this 11. This will helps to know this light it contains wave nature as well as the particle, that means the quantum nature. So both it contains the dual nature. So this the further study it is given by de Broglie, and the de Broglie wave nature we explained about and the display wave like properties, all those things, right? And in no experiment matter exists both as particle as well as a wave simultaneously. See, it is either the one of or other aspect. One is it may be wave nature or maybe like particle. The two aspects are that complementary to each other. And he suggested and based on the nature which allows symmetrical property, symmetry in nature, and the universe is also made of particles and the radiations of both entities must be symmetrical, right? And what is de Broglie wave and how he explained through his study? And see, according to de Broglie we can say a moving material particle that can be associated with the wave. That is, a wave can guide the motion of the particle, right? And the waves associated with the moving material particles are known as de Broglie waves, or we can call it as a matter waves. And what he through his expressions, that is according to quantum theory, the energy of the photon is E, which is equal to h nu. We know that, right? See, considering the photon as an EM wave of frequency mu and its energy from Planck's quantum theory we have taken, so that E which is equal to h nu. So we can write this as hc by lambda by relating wavelength. And according to Einstein's theory, the energy of the photon is what? E, which is equal to mc square. That is considering the photon as a particle of mass and the energy with associated with that. So that only the Einstein he given mass energy relation. So that only we got E which is equal to mc square, right? Now we can see that lambda which is equal to h by mc, or we can say lambda which is equal to h by p. So p which is equal to mc. So momentum of a photon, we know that. If instead of a photon we have a material like a particle of mass m moving with the velocity v, then the equation how it will change, lambda which is equal to h by, instead of p that is equal to mc, that is mv we have to apply here, h by mv, p which is equal to mv momentum. Got it, children? So this gives the equation of de Broglie, and de Broglie wave equation we can say. So what he concluded that lambda which is equal to h by mv, right? So de Broglie wavelength is inversely proportional to the velocity of the particle, and if the particle moves faster, then the wavelength will be smaller, right? So if the particle is at rest, then the de Broglie wavelength is infinite. So the wave cannot be visualized, and de Broglie wavelength is inversely proportional to the mass of the particle. So the wavelength associated with a heavier particle is smaller than that with the lighter particle, and de Broglie wavelength is independent of the charge of the particle. Matter waves like electromagnetic wave can travel in vacuum, and hence they are not mechanical waves, right? And matter waves are not electromagnetic waves because they are not produced by accelerated charges. And finally he said the matter waves are probability waves, amplitude of which gives the probability of existence of the particle at that particular point. So these are all the conclusion he had given for his point of explanation. Thank you, children.